Good morning, everyone. I want to welcome you to day 2 of the Trusted Computing Conference, the first full day of programming. I always like to start off with a little bit of humor, but apparently the Florida humidity has zapped me of all creativity. I guess maybe the one comment I would have for the conference organizers is that maybe next year we can get some longer lanyards. It's not exactly made for the size 19 neck on a gentleman, but it's the only thing I could really come up with. I also want to thank the Trusted Computing Group for inviting me to speak here today and present our panels this morning. I want to thank the sponsors as well. One thing I wanted to also thank was the attendees, both the vendor community and the security practitioners alike. As a member of the media, oftentimes we are guilty of highlighting just the failures of data security lapses and when trusted computing goes wrong. But quite frankly, we often don't have the opportunity to highlight the successes. I was taking a drive down to Monterey, California a few months ago to visit Dorothy Denning. Maybe some of you out there know her. Pretty big name in the security industry as far as an academic. And we were discussing what the industry has done over the last few decades to make the computing environment a more trustworthy one. And she pointed out to me that obviously the vendor community and the practitioners aren't doing too bad of a job, or else e-commerce altogether would probably be grinding to a halt. Nobody would be online, and the world as we know it certainly would not exist. So thank you to you all out there. I also want to commend the security industry for events like this where everybody shares information. Oftentimes criticized for being a bit closed when it comes to that, but I think it's actually just the opposite when you compare it to other industries around the world. So without further delay, I want to introduce our first panel today. Panel discussion, an introduction to trusted computing, very appropriate. Today we are moderated by Derek Brink, VP and Research Fellow of the Aberdeen Group. We also have Andy Musliner, a Chief Technology and Innovation Officer from DMI. Stephen Sprague, the CEO and President of Wave Systems, down at the end of the table there. And Michael Willett, Storage Security Strategist with Samsung. So, gentlemen, Derek, I'll hand it over to you.
Okay, thank you. Good morning, everybody. I thought it was cool that we could be here in Orlando on the peak day of hurricane season, which is what I heard on the news today. That's pretty cool. This panel is supposed to be a level-setting sort of thing because it was assumed that some in the audience might be kind of new to trusted computing. Others are obviously been around a very long time. So we're going to try to do some basic level setting here. With the panel, we have until about 9:45, so that's 45 minutes total, but we'll save a few minutes for questions. I see there's mics in the center, so we'll make sure to save some time for that. And I thought we could just get started with the basic question. We could try to define what is trusted computing. And in my experience in this industry for many, many years is that whenever you have some kind of positive adjective like trusted in front of something like computing, that usually means that you're trying to overcome something. Like I remember open VMS, kind of was by people who knew that VMS wasn't open, and so they had to try to change that perception. So I guess the idea that computing isn't trusted is part of what's going on here. But maybe we can just get some of our panelists here to weigh in on this question. Well, what is trusted computing? And Michael, I thought we could start with you. You could just help us understand at a big definitional type level what it is.
Okay, I appreciate it. For trusted computing, what do we mean by that? Let's take the terminology back to its basics, if you will, in language. As we did in the TCPA, many of you are TCPA alumni, the predecessor organization to the TCG organization. But we started with this definitional phase of what is trusted computing. Take it back to the word trust. What does trust mean? What is, in your mind, what does trust mean? Well, trust is, if you think about it, is a feeling you have about something, about a thing or the design of something. You have a feeling. Some of us even have a sensation of trust, but it's a feeling that has to be engendered in you about something. Like you trust your banker, or some few of us left probably still trust our banker, because we have an expectation of behavior. Right? Trust is an expectation of a certain behavior. or a certain outcome of a design of a piece of computing equipment. Right? So I know how it is designed. If it behaves as designed, then I trust that design, or I trust that behavior. So I can trust the banker because I know how bankers are supposed to behave, and if they do, I trust them. I trust computing systems because I know how they're designed to operate, what it should be doing, and if it operates as designed, then I trust that system. So the basic kernel word there, the root word is trust. But again, keep in mind, it's a feeling that you have to have. This is not, in a sense, when you say trust, you can't say the device is a trust device because it has to somehow, with its properties, engender trust in you. And then TCG has added certain other tenets to this definition of trust for computing systems that are sort of natural. That is just a few. One basic tenet of the trusted computing group for trust is what's called hardware root of trust. That is, there's a kernel of trust, an enclave of trust in the system that is built in hardware, or in some cases, highly assisted by hardware. Because there's a general sense that hardware can be better controlled, has more controlled interfaces. I understand the computing and so on that goes on with hardware. I have better control over hardware in general than I do in software.
And just a question for me, is that at issue? Is that point in debate? Does anyone say, oh...
I don't think so.
Okay.
So I would hope not. And we can argue that in the Q&A discussion here. And I'm saying general. Obviously you can find trust, untrusted, or untrustworthy is the better way to say it, hardware. But in general, in designing it to behave as expected, I have more confidence in hardware than I do in software. I just make a general statement, which has exceptions in both cases.
Can I make one more just quick observation? It's interesting to me that the definition of quality is it operates in accordance with the design as well. So your definition for trust is very similar to the definition for quality. Now, it doesn't necessarily mean high quality, it just means operates as expected. Right. So you're saying something more, actually.
Yes. In fact, if you look at it broadly, a criminal, you trust a criminal to behave as designed, which is a bad thing. Right? So, I mean, a criminal is doing bad things. But you can trust a criminal to behave a certain way. But I'm looking at the good aspects of trust here, in that sense. So, and one of the tenets, as I say, is the hardware root of trust, which means there's an enclave of trust, a little kernel of trust built into the larger system in hardware that forms sort of the kernel or the root of trust. And then we propagate that trust to the larger elements in the system. For example, the first specification we developed in TCPA/TCG was for the Trusted Platform Module. A little enclave of trust, a little embassy, if you will, in an otherwise foreign environment, a little safe haven in a larger foreign environment, where I can do certain cryptographic calculations with confidence, have trust in those calculations. But then I can use that to expand that to the whole system. I can develop, I can measure and calculate trusted or impart trust to software or the operating system by using the kernel of trust, the hardware root of trust in the TPM, and then propagate outwards to the system. And then beyond that, TCG has added a suite of security functions. We very much strongly depend on security standards, if you will. Standards give you openness, give you interoperability. Standards are typically vetted in the real world, so you have all of these are meant to enhance that feeling of trust that you have, that sensation of trust. And then we've also added just a few other usability, if you will, tenets. For example, ease of use, no overhead, robust, inexpensive, transparent, qualities like that, which are all, in a sense, part of the usability to you, but those are intended to enhance that feeling of trust. So trusted computing is designed, is technology added to computing in order to magnify and enhance your sense, your feeling of trust in those systems.
Now, just before we move on, Michael, to tie this into some of the comments Barbara Tonga was making last night in her remarks, she mentioned concepts like principle-based and standards-based, and so the trusted computing that we're talking about here is consistent with those. Can you just make that connection for us?
Oh, very tightly. I mean, standards-based, hardware-based. I don't know if not so much explicitly last night, but in the previous NSA conferences that some of you attended over the years, they put a very strong emphasis on hardware, roots of trust, And by the way, just as a plug, I'm sure it was just an oversight that she didn't mention not just the TPM, but the self-encrypting drive capability and some of the other TCG technologies that they have endorsed previously in other settings.
All right, thank you. So, okay, that's a great start, thank you. And this, to me, of course, makes the inevitable next question to be, so what? So we have trusted computing, it's designed to solve certain problems. So maybe I can ask right down the row here, Andy, can you give us a sense of some of the problems that it can solve, and tangible examples, because we have limited time. So not the academic, more abstract things, but tangible things that it's designed to solve.
Sure. And just to build on what Michael said, I think it's an important point to note that the reason trusted computing starts in hardware is that software is inherently vulnerable. That is, if I have software, there's typically a way that I can go compromise that software, either locally or remotely. And so the best thing to do to prevent that, the best thing that anybody's come up with to do to prevent that on a mass scale is to move the trust from our belief that software is trustworthy down to hardware, which is more trustworthy. Why is it more trustworthy? Because it takes a heck of a lot more money and time to build. So, I can put a standard out there for hardware trust, and it'll take $6 billion to build a fabrication plant, to build it in a number of years to put it together, as opposed to software, which I can put together in a few days. So, if I can build the hardware much better, then I can establish trust down at that level. And I'm not going to bother to go into supply chain trust, because that's going to be a whole other conference. So in terms of problems that it can solve, so the whole idea here is that if I can take something like the Trusted Platform module that Michael mentioned, which is a security chip that's on millions of devices already today, I can get below the software. So I can establish that root of trust, and I can get below the software, and that enables me to do all sorts of things. So I can use that TPM as a security chip to do things like protect credentials. So rather than store them in software, where they can be stolen actually in less than 30 seconds, I can store them in hardware or protect them by hardware, and that way they cannot be remotely stolen by somebody who may be trying to access my machine. I can also do things like determine what's on my network. So from a very practical perspective, today, if you go to your enterprise and you go to the IT department and you say, okay, give me an enumeration of all the devices that are on our network. Unless you're a company or an organization that can literally walk around the halls and count, chances are they only know about as much as 80% of the devices on their network. So that leaves 20% that they're not really sure about. Well, it only takes one bad actor to make a whole lot of damage. So if you're missing 20% of your network, then that's a really bad thing. So when I can establish a hardware root of trust and I can identify a device for sure, then I can now enumerate the devices that are on my network, and that closes a gigantic hole that's in our security today. There's a lot of other stuff I can do. So if I can trust the device, then I can start asking questions like, well, how much do I trust the device, and therefore what can I give it access to on my network? So I can give certain granularity to what I give access to on my network. I can also start establishing trust levels in the software that is on the device. So I start down at the hardware and I start building what's known as a transitive chain of trust up to the software, and I can start establishing that certain software is trustworthy. Now, wouldn't that be cool? Because now I can have that confidence that Michael was talking about, that when I run this software, it's actually the software I expect to run, and it's going to behave the way I expect it to. So that's a very cool thing. And there is now, this stuff is now becoming available as technology is evolving, so that I can actually establish a certain confidence in the level of software that I have.
Can I ask just a clarifying point? The way you're describing it here almost seems like you're describing, by analogy, plumbing. And you can say, with plumbing I can wash the dishes, or I can take a shower, or I can, wash the dog, but people aren't interested in how the plumbing works generally. The homeowners, that is, they just want to wash their hair when they need to wash their hair. So, I think...
So more practically?
Well, maybe, sure.
Well, no, it's an important point. So yes, you're right. So I'm establishing the fact that trusted computing ultimately becomes like the air we breathe or the water we plumb through our houses. We don't care about the fact that it's there. We just care that it works. I'll go to the self-encrypting drive as an example, just switching directions. So, big problem would be, what happens when my laptop gets stolen? Well, if I've got a self-encrypting drive, my IT department can brick that drive remotely in a second. So that's a lot better than kind of the old days where I would have to, spend 7 hours. Well, I'd have to first find the drive, and then I'd have to figure out how to wipe it. So you've got that sort of capability. So a very practical approach. And I'm sure that Stephen's got some other practical approaches. But I can do things like I can have secure voice communication. So I can tie the encryption into hardware, and I can ensure that I've got secure voice or secure texting or secure any other type of application by tying the security down to the hardware itself. Let's see. I guess that's a good start.
Okay, yeah, it is a good start. Well, let's get Stephen involved in. I have had the pleasure of knowing Stephen Sprague for many years. I was a product manager at RSA when I first met him, and he's been an evangelist since that day and prior. But he's one of the best I ever have met in evangelizing the vision for trusted computing. And the thing is, and maybe the point of my last question to Andy was that I don't think a lot of enterprises buy technology based on vision. Majority of them anyway don't. They're certainly early adopters. So Stephen, maybe you can help us just name one of the many business cases for trusted computing and really keep it at the business case level if you could. Why should we move forward with this today as opposed to waiting, or what's the benefit of the most typical alternative to trusted computing based applications?
Thanks, Derek.
And just one, by the way, we might have time for others.
We'll pick one. I think self-encrypting drive is a good place to start. It's a technology that's been out there. It's pretty well embodied. It does just a couple of things. So it's relatively simple to think about the role of why should I use a self-encrypting drive leveraging trusted computing local standards versus the hundreds of different ways that I could do encryption within a platform. I could encrypt just the files or the whole disk, or there have been lots of different schemes that have been deployed in the marketplace today. And what I find fascinating in this process is that standards have given us an incredibly powerful set of tools to provide not only strong encryption, but very strong user-to-device binding. So if you actually read the OPAL standards, there's very little discussion about what cryptographic method should be used within the device. The real discussion is, so what's the experience to bind a user to a device? And everybody in this room has one of those devices today. You have a cell phone with most likely a PIN number turned on. Well, what if you forget your PIN? And every different network has a different scheme on how do you recover your PIN. In most cases, you don't have to throw the phone away and get a new one. But also, how do I prove the PIN was set when I lost the device is an interesting one. And what's been fascinating about self-encrypting drives has been everybody buys the wrong thing. So everybody wants to know how strong the crypto is. First question is, can NSA break the crypto? Well, that's actually kind of almost a silly question. Let's encrypt it 3 or 4 or 5 times. I mean, we can make the math really hard to accomplish. But it's not about the strength of the crypto. The real question is, how good is your proof that when you lost the device, it was encrypted when lost? Because that's what you want to know. No one ever asks the IT manager, well, how strong was the crypto on the device we lost? No. They ask, was it encrypted? And what's interesting now is that proof of encryption is really where the rubber meets the road. And so when you look at the business case for trusted computing, it turns out that you can't do BYOD in probably most of the industries today. So the emperor has no clothes. You can't do BYOD. Why? Because you can't prove the device is encrypted if you don't control it. So how do I prove? So let's pick an example. We'll give Michael Willett a machine. We'll make him the full administrator of the machine. We'll give him a self-encrypting drive, and he gets to set up and configure the software himself. So he's full administrator. He can turn it on and off 4 times an hour, no trouble at all. it doesn't take very long with a self-encrypting drive. You turn it on and off in a second, so very easy to do. So he loses his machine. How do we know it was encrypted when he lost it? Well, we can ask him, do you think he's going to lie? So let's see, you lose your job, you go to jail, you have to stand up in front of everybody and say, I lost my machine, or if you tell us it was encrypted, nothing happens. You don't have to have gone through too many years of school to figure out what the right answer to this question is. And so proof a device is encrypted when what we have is a hostile user, the administrator of the machine. It's a classic insider attack to lie that your machine, of course, was encrypted when lost. And so how do we do that efficiently and effectively? And that's what trusted computing provides, is not only do the drives have no impact on performance, they're typically cheaper to procure because of that performance impact. So a little known fact is a standard rotating Seagate drive with 2 gigs of RAM running Opal is faster and cheaper than the same exact computer with 4 gigs of RAM running BitLocker as a software encryption scheme. It's not a huge difference, but you need 4 gigs of RAM to duplicate on the same platform, same processor performance. Turns out that the Opal option has, for years, even since launch, been cheaper than 2 gigs of RAM. So I just find that entertaining. So everybody who has software encryption deployed, just understand your IT department bought the slower, more expensive computer because that's what procurement did after 6 months of evaluation, of testing and qualification. They forgot to run PC WinMark. So then you come to the second piece, which is, so now I have this deployed machine, I've paid for the technology, but what do I have to do to provide proof? And it turns out we're really good at proof. If you want to understand proof, we have a whole industry that loses things, and then after they lose the thing, they want to know what happened. And it's the airline industry. So if a helicopter flies off the coast and falls in the ocean, what do? We go get the maintenance logs, because clearly somebody put the wrong turbine blade in the helicopter and it blew up and it fell in the ocean, and it cost you $10 million. And probably a couple of lives. And the couple of lives things clearly changes the picture, because then we get serious about the proof that what was in the air is what went into the water and what actually happened. And fortunately, with self-encrypting drives, we don't tend to kill people that we know of, right? I mean, information is an interesting and powerful weapon, but we tend not to be able to connect it to people who get killed. And so proof is a really interesting thing. So you can make a software encryption product completely provable, but your maintenance procedures have to be much more substantive, and you have to be willing to pay for all those hours. Who's in charge, who re-imaged the machine, when can it be done, etc. And so
you're clearly making a compliance case as well as a security case here. That's a big part of it.
It is fundamentally the reason that people are buying it is compliance. Yeah. It's satisfaction that the machine, when you leave it somewhere, is encrypted. So I left my machine in my room, right? So the evil maid attack that happens at the Rosen Hotel, because we're here at the Trusted Computing Conference, so if you were the Chinese and you wanted to find out what was going on in Trusted Computing, this would be a good hotel to have put temporary staff in to empty our rooms.
I have to excuse myself for just a second.
So the question is, how many people are now comfortable if in the cleaning process of your room this morning, everybody's hard drive is going to be cloned? I'm comfortable. Because unless my hard drive's not there when I get back, it hasn't been cloned. And it's probably safer than ones that have type 1's fancy encryption around it, because it turns out that I can't actually copy the drive. Stealing the thing encrypted, well, we all know that you can go get a supercomputer and ultimately break the crypto. And it might take a really long time if it was a targeted drive. But it's hard first to actually steal it and not detect that it's been stolen.
When you make your case here, I've always found in the realm of security, there's kind of 4 buckets of value, and there is risk or security, if you will. There's compliance. There's cost, which you've touched on, and sometimes there's an enablement. Not always though. But you're making a very strong case on the proof side. How would you prioritize the benefits that you mentioned? Is it cost? Is it compliance?
So you're going to spend money on compliance, and what you have to do is prove a device is encrypted when lost. You should buy proof. Buying encryption is a silly thing. And then the question is, what are the byproducts? So we have a very funny experience where actually the person who we sold the technology to now works for Wave. So you can put a qualifier on it a little bit. But his comment back was that we totally screwed up the ROI calculation, or the TCO kind of calculations that we did ahead of time, because it hadn't dawned on us that because the access control of the machine was now driven by the hardware of the drive, what they gained was they could reset machines for lost passwords that were never connected to the domain again. And so it reduced their help desk costs by millions of dollars. And actually, the entire program was paid for by the savings in help desk costs on the recovery basis of the drive. We have a second customer who's out there who's deployed smart cards in combination with drives. 1% of their employee base forgets their smart card every morning. Just 1%. The difference is they've created a self-service mechanism on their domain. They can go up to any other person's machine on the domain and get a recovery password for that machine, boot it, and not require their smart card. So they've been able to duplicate it.
You're sliding into the second example, which I promised I would hold you. But
no, and I appreciate it. I wasn't actually trying to do that. The point is that they use the drive mechanism as the recovery mechanism, and so their recovery costs were based entirely around the self-encrypting drive, providing not only the benefit of proof of encryption, better performance, but the ancillary benefits actually ended up paying for the whole program.
Yeah, thank you. And this is excellent foundation. Thank you for everybody. I do want to move it in a slightly different direction, or maybe up a little bit, to just talk about where we are in the realization of this path. Now, you did, Michael, about the predecessor organization to the Trusted Computing Group. I saw in the hall, TCG is 10 years old. The Trusted Computing Platform Alliance was before that. And so this is not exactly an overnight success story. But this is not atypical. My experience in these things, I've been involved in a few personally, is that there's, these organizations get together, they launch, there's some kind of excitement about how many members and the names of the members, and there's growth in membership, and then there's a specification that's developed, and then we have reference implementations finally, and then a critical mass of implementations, and maybe there's some interoperability testing and certification that goes on, and finally there's some applications on top of these specs, and then there's early adopters and so on and so on. So finally we get to ultimately deployment at scale. That's the end of this game. And I guess I want to ask everybody where we think we are. And there's always this chicken and egg dynamic that applications don't come until the platform's there, and the adoption doesn't come until everything's availability and tested and proven. And so Michael, just maybe I'll start with Andy this time to change it up a bit. Where are we in the cycle, and why do you think that it's going to ultimately come to pass to full-scale deployment like we all hope?
That's a good question. So I think about this too much because kind of like Stephen, although not nearly as long as Stephen, I've been working in this space for a little while, and I keep wondering, so when is everything going to happen? I mean, plumbing has to. We all need plumbing. So I think that we're just about at the top of the peak where everything starts rolling down the hill, and I'll try to illustrate why I think that. So one of the key things is, trusted computing is based on hardware. It takes a while to get hardware to change. Unlike software, which I can rewrite very quickly, hardware requires, as I was mentioning, a fabrication plant. I've got to have new dies. I've got to have all this stuff put together. So if we go into major hardware manufacturers and we say, okay, guess what, guys? We're changing the way plumbing is done in all of your hardware. Here's the, adopt this trusted computing standard, employ it in your designs. They say, well, okay, that's going to take, even if we believe that that's a good idea, which they pretty much are of that belief now, it's going to take a while. But you see that stuff rolling off the assembly line now. So you've got companies like Microsoft that are requiring a TPM inside for Windows 8. That's a marvelous indicator, if you will. And while Windows 8 hasn't necessarily become the de facto standard for everybody on the planet, because it takes enterprises a while to migrate, it's going to be a significant thing inside the enterprise. And so therefore, TPMs are going to be required for use. And Windows 8 uses the TPM for things like trusted boot. So that's a good indicator. I believe that once the hardware gets past kind of this hump where it's all built in, software is much faster. And so the software is like the ball rolling down the hill. So as we get platforms in place, especially for mobile devices, and there's one or two out there right now, but they're working their way towards it. That's going to be the thing that starts tipping everything downhill. It'll be smoother sailing at that point. So all of us who have been kind of hanging in the balance for a while can, I think, rest a little easier at that point.
Okay. Michael, is anything, I mean, 10, 12 years ago, we were dealing with a lot different things, or say it the other way, we're dealing with a lot different things today than we were 10, 12 years ago. Is there anything going on now that is going to help us get the downhill run going?
Well, I want to make two comments, and one is based on Andy's observation, your question to him. One of the continuing challenges, as we all know, that work in trusted computing is marketing trusted computing. And the essence of the problem, as I see it, and by the way, we had a table going last night that after a couple of beers, we really got into this subject of how to market trusted computing. And it's a challenge, and the reason I see it as a challenge is because the very tenets of trusted computing fight against the market in this sense. If you have technology that is transparent, easy to use, unnoticeable, no performance impact, built in, not built on, I don't want to see it. It's invisible. The discussion last night got into almost theological realm of this discussion because in a sense, the trusted computing, to market it, you want people to appreciate it. Yet it's not visible to the average consumer. So that's the challenge. It's a challenge we face. Because as Derek indicated, we don't want to sell the plumbing, but it's the plumbing that's transparent that gives you all the facilities and the services on the outside. And that's what Andy spoke more of. We really have to market to the functionality that is provided on top of the trusted computing plumbing. But again, marketing of trusted computing is a continuing challenge. Secondly, I think what we need to do, every few years we kind of hook hook wagons to horses, right? We hook our wagon to the fastest horse in town and see where it takes us. And one of the jargon terms that I've seen, if you do a linear inch devoted to this term, it's not even in Webster's dictionary, is consumerization. So you see consumerization everywhere. It's not even defined. But let's try a definition. I would see consumerization means I want to bring of anything, of a technology, of a thing, of a business. Consumerization means let's look at the prototypical consumer on the street. That's me and you. What are our expectations, you will, of the thing? Either it be technology or whatever. If I am given a thing, what are my expectations? Well, I would hold that the tenets, if you will, of a consumer, prototypical, are ease of use, no overhead, robust, inexpensive, transparent. I want my technology, in a sense, the part that's the plumbing, to have all those properties. So consumerization means bringing that consumer mindset to the thing. It be IT, because you see a lot of work on consumerization of information technology. You see it all in the fast horse in town is the BYOD, bring your own device, right? It's a lot of discussion of I want to have a consumer mindset about technology, but allow it to come into the workplace. Ease of use, transparency, all of those things. So what I want to do then with that term is to do a little triangulation. That is, and some of you, the more mathematically inclined, will conjure up Venn diagrams with overlapping circles here in just a second.
I'm a mathematician.
There we go. I've got some conjuring going on already. So I have this consumerization idea of IT. I have the tenets that we've already talked about of trusted computing, which are what? Which are, well, there's hardware roots of trust, standards-based, security functionality, but it also includes those things which enhance that feeling of trust, right? Such as ease of use, no overhead, robust, inexpensive, transparent, built in, not built on. If you see the triangulation I'm drawing is there's a consumerization of IT, but within that, the trusted computing group, as the third one of the circles, is providing the same tenets in its technology as a consumer is expecting in the IT world. So if I just do a triangulation where I have the consumerization of trusted computing, I think completes the picture. So that's, I see, is a if you will, a wagon we can, a horse we can hook a wagon to, right, and ride through. If we're looking for a way to merchandise or market, is to identify with what's already a hot button in the industry, BYOD/consumer/consumerization, and say that's just what trusted computing is.
You might actually have a talk kind of along those lines.
Oh,
is that right?
By the way, I'll elaborate on these points in my afternoon talk.
So Michael, I would add one point to that, which is I think the transformation that's really underway is that we're moving from a world of a monolithic collection of devices, the corporate image running on a PC, to a really broad array of devices. And the problem with a broad array of devices is they won't have the same capabilities, period. And that while we can do all these crazy things to try and add stuff to smartphones to get them to equal a PC, it's just not going to happen. And so what's happening is that a reliance on the capabilities of the device becomes important. And so now I have a network of known devices with known capabilities before I'll deliver the service. And so we can't tolerate anymore the idea that I bring my iPad to work and I want to connect it and download the 100,000 patient records, but it has no encryption solution. And so what should happen is the download button shouldn't appear. So I can still go to the site, I can see all the information on my iPad, it's a great window into the internet, fantastic. But if I want to take the data with me, I have to train the consumer to ask for a device that has the capability. You wouldn't hook a Corvette to a 6-horse trailer. It has the same torque, it has the same horsepower, it just doesn't have the right suspension system. And so you have to buy an application-specific vehicle for that application. And I think the same is true here. If I gave you the choice that says, this iPad, you can work online all you want, this Windows tablet with a self-encrypting drive, you can download the content and work locally. And then I give you a 2-hour commute on the Washington Metro. Which one are you going to buy? Well, you're going to buy the one where you can download the stuff and work locally because the Metro Wi-Fi sucks. Right? And you'll easily make that decision. You'll make that decision to the tunes of hundreds of dollars difference in devices because you're going to want to take advantage of that 4 hours a day you're sitting on the Metro from a productivity perspective. And we're not giving that choice yet to the consumer.
Personally, I think the financial argument is the one that does have to be made. The other vision in the world can't overcome the financial motivations. Are there questions that the audience has? Now would be the time to ask. We've got just 5 minutes. Go to a mic and ask away.
Uh-oh. We know that guy.
So I have a question about media. And the way the media, is this on?
Yeah.
The way the media considers trusted computing, because it seems like antibodies have come out against the defense of computers. And a perfect example of this is this nonsense that was printed about the German government saying that the NSA is inside TPMs that came out a couple weeks ago. And the media didn't do any investigation at all. They would have realized that Infineon, a German company, is president of the board of directors of TCG. They produce most of the TPMs. The certification is done to EAL4+, which is done in European labs, and I think they actually had theirs done by a German lab. And so just a small amount of investigation would have revealed how stupid that article was. And yet it got plastered everywhere. Why is this?
So,
Please, yeah. I'm just the moderator here. I cannot answer that question.
so I'm only going to answer it sort of at a macro level, since I don't want to get into politics. So there's this marvelous saying that goes, you know, it's easy to predict the future, it's just hard to predict when the future will come. And so I came up with a corollary to that based a lot on this media frenzy, and that is the closer you are to the future, the more people talk about it. So I personally believe that, you know, because we're nearing that crest, that it's stirring up a lot of fear, uncertainty, and doubt, and the more, you know, that's going to happen a lot, and, you know, eventually that will all just go away.
It's not going to go away. We've lived this for a really long time. I've been a part of this since, you know, the Secure Digital Music Initiative with 1,000 people sitting in the room talking about securing music. The fundamental problem is that privacy and the terms used wrapped around privacy and the controls required to deliver privacy are that I, as an owner of the content, need to publish that content in a manner where it can only be used according to rules that I would like to set. That's what privacy is, right? So I want to write something and only send it to Ed, and Ed's the only one who can read it. Excellent. It turns out that the definition for protecting the latest Disney movie, as long as we're sitting here in Orlando, is exactly the same. That the economic controls necessary for Disney to control their intellectual property and the mechanisms for privacy are the same. And the concern that sits out there is that somehow, in some way, the concept of trust is that someone who can trust that platform has an expected outcome when they put a known input in. And the challenge with that is it depends on who's wanting a trusted execution application. So you can write an application that will prevent other things from happening. And so there's a sense that theft should be rampant and allowed, that hacking should be rampant and allowed. So I should be able to modify my operating system and insert bad code. That's my right, it's my platform. And of course the contrast to that is that fundamental openness of a compute platform, once you begin to lock it down so that I can assure that the code that is running is the code that came out of the Microsoft factory, because that's what most consumers want, is that the act of locking that down creates protections against the person who wants to modify it. And so I think this is going to be a consistent battle, and I do think that what's really important is that the facts come out. You know, this conversation started a year ago when Microsoft announced that they were going to use UEFI and the protections of secure boot, and that somehow we couldn't run Linux anymore. No, you can run Linux if you want. It's just that then you lose some of the capabilities in secure boot, or the Linux code has to get signed, one of the two, in order to get to a platform again that you can have the same level of trust on. Nobody's preventing your ability to send binaries to a processor if that's what you want. And I think that that's where the tension is in this market, is that there are needs for controls, and then there's concern about controls. So trusted computing allows me to run software that by its nature I shouldn't be able to see the execution of. But it's also not anonymous.
Thank you for that. I'm afraid what's happened on this panel is what happens on every panel that I've ever been on, which is that we've run out of time. Unless we have a grant of more time, which I don't forget. One more question. We can have one more question. A bonus question has been granted. So if anyone has one, why don't I just offer the panelists a chance for just a few quick comments of last word.
Just to follow up on what Dave asked, it's part, as I said earlier, it's part of the core challenge we have in marketing trusted computing. Is the very invisibility and the transparency and so on of the technology. Unless you see the application, the use of it, you take it out of the plumbing and into the world where you see the applications. It's a challenge to market that plumbing, which we're going to deal with. And secondly, I think, in terms of the German issue, the BIS issue, we break into two camps, right? There's the people that are inclined to not trust anything, or they're inclined toward distrust, and those that are inclined toward trust. And the very definition of behaves as expected and so on, that sort of behaves as designed. So I think that the press has just been merchandising themselves to the inclined to distrust. There's always going to be that percentage of the population that it wakes up distrusting. And hopefully some of us in the trusted computing world wake up and go to sleep trusting our technology.
Please.
But isn't it so that we often take our own worst enemy? Because so we're just looking at the segment of encryption. The IT organizations out there, they know we have to encrypt, or finally they start learning about it, that we should encrypt. Now, the members of the TCG, member groups of the CCG, we're already there confusing the market. We're going E-drives, we're going BitLocker, we're going Opal drives, and no encryption. So, we as member companies, we bring all this out there to them, don't really give them any help, but say, figure out, go with trusted computing. It's a confusion to the market.
So the thing that solves the confusion in the market, or has the potential to solve the confusion in the market, is demand. In the sense that, Deb Plunkett did us all a big favor yesterday in saying that she's going to start requiring TPM use for national security systems. That is one of the big signals that, those of us in this industry have been waiting for. A buy signal. I mean, everybody who's in the IT industry wants to sell. Everybody, wants to find a buyer. So the big trick here is you find some buyers. If the U.S. government becomes a big buyer, then that's part of the train moving down the hill. And I think, while I'll agree with Stephen that the problem will never go away, I think once the train is moving down the hill, that problem becomes less and less of an issue. So I didn't mean to imply that people would stop arguing, only to imply that it will become less and less important as demand picks up.
I think it's discovery of economics. I think at the end of the day that we have an interesting scale opportunity these days we're pursuing that it just dawned on them that device is the token. It's like, really? So you mean when you use your cell phone, you can type in a pin. When you use your iPad, you can type in a pin. When you use your PC, you got to get that other thing out of your pocket, wait for it to come up with a code, type the code in, etc. So why is the PC somehow pushed to the side to have this extra work that you don't have to do on your phone? You have a 4-digit pin on your phone, you're all set. Maybe 8, So I think the discovery of the economic value where you realize that all of a sudden my device is the token. I shouldn't have to go find my phone and wave it in front of my PC. I can just type PIN number into my PC like I do into my phone. And when they start doing the math, it's almost fascinating to watch the sort of discovery of the process. They're like, the customer we're talking to, the cost of the solution will be less than their FedEx bill for replacing the tokens.
So that will have to be the last word for this panel. Thank you to everyone. Thank you for being here. Sasha, you'll tell us what happens next? Okay. Thank you.
So we will just have a short 5-minute break, and we'll be back with Glenn Pittaway from Microsoft. So water in the corner. Thank you, panelists.